In this video, we solved problem 14.1.025 from Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to evaluate the iterated integral, and it happens to be in polar coordinates. And remember how this works. You're going to start on the inside and just work your way out. So I'm going to ignore this integral from 0 to pi over 2 for right now, and then just focus on that integral on the inside. That's the integral from 0 to cosine of theta of r with respect to r. So again, we just stay on the inside, evaluate that innermost integral, and we work our way out. So the first thing we do is we take the antiderivative of r with respect to r. And that just requires a power rule. There's an implied 1 there. So we add 1 to the exponent and divide by the new exponent. And then we evaluate this from r equals 0 to r equals 6 times cosine of theta. So you're just going to substitute those in. It's just an application of the fundamental theorem of calculus. Plug in the upper limit, you plug in the lower limit, and you subtract. You could factor out that 1/2 if you want to. So you've got 1/2 times the integral from 0 to pi over 2 of 6 cosine of theta squared minus 0 squared. That's our new integrand. Sorry, had a little something in my throat. And then of course we want to simplify this. You've got something times something else squared, so you want to square this and square that. 6 times 6 is 36, so I will factor that out. And then I have the integral from 0 to pi over 2 of cosine squared theta. And of course, 36 times 1/2 is 18. And we're here. Now, cosine squared is not a function that we have a basic rule for, so we've got to do something else. We've got to rewrite it so that we do have a basic rule for that. In Calculus 2, we talked about using power reducing formulas. Anytime we have cosine or sine raised to an even power and there are no cosines or sines raised to odd powers, we use that power reducing formula. So according to the power reducing formula for this, it's the power reducing formula for cosine squared. Cosine squared of some angle is 1/2 of 1 plus cosine of twice the angle. Whatever that angle is, you're going to double it. So this can be rewritten as 1/2 of 1 plus cosine of, that's an angle of theta. I want to double the angle, so it's 2 theta. And of course, we're integrating with respect to theta. The 1/2 times the 18 is 9. And then we've got basic rules for everything up here. So at this point, we can just antidifferentiate with respect to theta. And then we'll use the fundamental theorem of calculus. So you bring the 9 down. The antiderivative of 1 with respect to theta is theta. The antiderivative of cosine of some angle with respect to theta is sine of that angle. But if you've got a constant times your variable here, we need a 1 over that constant out front. This is that kx modification of our basic rules that I mentioned in Calculus 2. So if I've got 2 times theta here, if I were to take the derivative of this, I'd have to multiply by an extra 2. When I take the antiderivative of this, I divide by 2. Because we're undoing that, we're doing it backwards, right? And we evaluate from theta equals 0 to theta equals pi over 2. So we'll have 9 times the quantity, pi over 2, plus 1/2 times sine of 2 times pi over 2. And then we will evaluate the same expression at 0. So you have a 0 here and a 2 times 0 here, but sine of 0 is just 0. So you've got 0 plus 0, which is 0. So this whole term zeroes out. This is us just doing that last part of the fundamental theorem, plugging in the upper limit and plugging in the lower limit and then subtracting. And then over here, this turns out to be sine of pi, and sine of pi is 0. So we end up with 9 times pi over 2, or 9 pi over 2.